Hi everyone. In this lesson, I want to look at some quadratic functions and their graphs. And in the following lessons, in particular, we're going to look at what happens to the graph of a quadratic equation when you tweak it by adding numbers and subtracting numbers and so on. So we want to start off with where we will consider a basic function y equals x squared. And let's just plug some numbers in to get an idea what that looks like. Notice if I plug in 0 for x, I would get y equals 0 squared, which is just 0. And so this is a point on that graph. Notice also if I plug in a plus 1, 1 squared would be 1. Or if I were to plug in a negative 1, negative 1 squared would also be 1. So here's two more points on the graph. Looks like this. If I were to plug in a plus or a minus 2, 2 squared is 4, negative 2 squared is 4. So here's a couple more points on the graph. Okay, now I can plug in some other ones, but we end up with a parabola that's going to look something like this. Okay. And that's my basic graph of y equals x squared. Well, what's going to happen if I were to graph x squared plus 2? Well, let's plug in the same 0. I'm still going to get 0 squared is 0. That would be this point. But then I add 2 to it. So instead of being here at 0, it gets moved up 2 to right here. If I were to plug in plus or minus 1, I'd square the plus 1 or the negative 1. That'll give me 1 here. That's the same as these points right here, right? But then I have to add 2 to it. So 1 squared is 1 plus 2 is 3. So instead of being here at 1, I'm sorry, right here is 1, which is where it was over here, it's going to be moved up 2 to right here, which gives me 3. If I plug in plus or minus 2 into this function, I'm going to get 2 squared is 4. Now that's what I would have gotten over here, right, if I just had x squared, if I didn't have the 2. But then I have to add 2 to it. So that's going to give me 4 plus 2 is 6. So that's going to put me a little off of my graph here. But you notice, and this is the point, that it's the same graph we got in the first picture. It's just been moved up 2. Every one of the points has been moved up 2. Okay? So notice that this graph moves up 2 from my original graph. And if I were to have x squared minus 4, well, let's plug in 0 again. 0 squared is 0. But then I'm going to subtract 4. So instead of being right here at 0, like we were in my original x squared graph, that got moved down 4 units, so it's going to start right here. If I plug in plus 1 or negative 1 and square it, and that'd give me 1, but then I'm going to drop down 4. So instead of being here like I was on my original graph, it's going to come down 4 units, and that puts me at negative 3. All right. If I plug in plus or minus 2, 2 squared is 4, and 4 minus 4 is 0. So instead of being at 4 up here at 2, it got moved down 4 units. And again, it's the exact same graph as I had over here, but the whole thing has just been moved down 4 units. Okay? So this one moves down 4 units. Well, I'll bet without graphing, you would be able now to understand that the graph of y equals x squared minus 8 is going to look just like y equals x squared, but it's going to be moved down 8. Okay? And y equals x squared plus 12 is going to look just like y equals x squared, but it's going to be moved up 12. Now let's just check that on my graphing calculator. Let's go over here and let's graph x squared. Okay, and let's graph x squared minus 8. Let's just graph that on my standard window here. So here's my normal x squared, and you see that x squared minus 8, yep, it's the same graph, it just got moved down 8 units. And if I were to graph x squared plus 12, that's going to be the same graph moved up 12, but I'm not going to see it because the 12 is up here, right? I'd have to go and change my window. Let's change my y value in my window to go up to, like, say, 20. And then I'd be able to see that, okay? So here's my normal x squared, and there's my x squared minus 8, and here's going to be my x squared plus 12. Okay. So Let's do another example. Now let's tweak this function in a different way from the ones we did above. Again, let's look at y equals x squared. Remember, I had these main points right here. My main point is the vertex at 0, 0. And if you go 1 on either side of that vertex and go up 1, that's a point. And if you go over 2 and up 4 on either side of the vertex, that's another point. And so this is my basic y equals x squared graph. All right. Well, let's look now at x plus 2 quantity squared. Now notice how this is different from the one I had above. Above I looked at y equals x squared plus 2. Here the 2 is not on the inside of the square like it is here. All right, so this is the one I want. And I'm going to plug numbers in just ever so slightly different. Notice that if I wanted to get 0 out of this, I'd have to plug in negative 2. Negative 2 plus 2 is 0, and 0 squared is 0. So I know that negative 2, 0 is one of the points on this graph. How about if I plugged in negative 1? Well, negative 1 plus 2 is 1, and 1 squared is 1. So here's a point on the graph. How about if I plugged in negative 3? Well, negative 3, if I plug in negative 3, I'll get negative 3 plus 2. That's negative 1, and negative 1 squared is 1. So here's this point. Okay? Well, how about if I plug in 0? 0 plus 2 is 2, and 2 squared is 4. How about if I plug in negative 4? Negative 4 plus 2 is negative 2, and negative 2 squared is also 4. So what you should recognize is that this is, again, the exact same graph I have as x squared, but it's just been moved 2 units to the left. Okay, so this graph just moved the x squared graph to the left 2. Well, what do you think x minus 4 quantity squared is going to be? Well, notice that if I plug in x equals 4, that'll give me y equals 0. So here's a point on that graph. Let's plug points on either side of that, because this really is the vertex point now, isn't it? So if I plug in 3, 3 minus 4 is negative 1. Negative 1 squared is 1. And if I were to plug in 5, 5 minus 4 is 1 squared is 1, and 1 squared is 1. Okay? If I plug in 2, I'll bet you see I'm going to get 4 without plugging in anything, right? 2 minus 4 is negative 2, and negative 2 squared is 4. So again, it's the same graph. It's just been moved, in this case, to the right 4. All right, so without graphing, I'll bet you can tell that the graph of y equals x minus 8 squared is going to look just like y equals x squared, but it's going to be moved to the right 8 units. And x plus 12, the quantity squared, is going to again be the same graph, but it's going to be moved to the left 12 units. Okay, let's just verify that on our calculator. Let's go to our calculator here again. Let me delete these two. Let's go ahead and leave the x squared. So at let's look at x minus 8, parenthesis x minus 8 squared. And let's also go ahead and put in here parenthesis x plus 12 squared. Let's hit our standard window again. So here's my normal x squared. Now the x minus 8 squared, yep, there it is. It's over here, moved 8. And this one over here, if I move it 12 to the left, it's going to start over here. So you can just see where that is coming down. Let's change my window ever so slightly. Let's go from, like, say, minus 15 in the x direction. So again, here's your x squared, here's your x minus 8 squared, and over here is your x plus 12, that quantity squared. Okay? All right. So notice then that when you tweak a function on the outside, like if I have y equals x squared, the 2 is on the outside of the square, the function is always going to move vertically in the direction you'd expect. So if I tweak it with a plus 2, then it moves up 2. That's what I'd expect. When you tweak a function on the inside, though, with like a plus 2, x plus 2, the quantity squared, notice the 2 is on the inside of the square, then the graph moves horizontally, and it moves in the direction opposite to which you would expect. Right? If I tweak it with a plus 2, it's not going to move it to the right. That would be horizontally to the right 2, right? It actually moves it to the left 2. And so that's the way it'll turn out for really any function, but in particular in this section and the next ones we're looking just at the x squared function. So if you tweak a function on the outside of it, it moves it vertically in the direction you expect. If you tweak it on the inside of the function, then it moves it horizontally in a direction opposite from what you would expect.